Flip-flop is a basic element of a memory. Memory means it can store a bit as long as it power supplied. That means it can store any data. Okay, so we can say that flip-flop is a basic element of a memory device. Now here flip-flop may some category. One is RS flip-flop. Okay, RS means reset, set, flip-flop. R for reset, S for set, and flip-flop. A flip-flop, as stated earlier, is a bistable circuit. That means both of its output state are stable. That means the output, it has two output, and two output are stable. The circuit remain in particular output state indefinitely until something is done to change the output status. That means if you not want to change the output of this circuit, it cannot change. It can store this data for indefinite time. That is why it is used as a basic element of a memory device. Okay, now first we see the circuit. See here, it is a basic circuit of a RS latch. Okay, see, the circuit diagram is made by the NAND gate. Siddharth? I told you. Latch is a same of flip-flop without controlled by any clock. Okay, when it synchronized with a external clock, then the latch is called flip-flop. So you may call latch is a basic element or first stage of a flip-flop without clock. See here, two input, one is S, one is R. You may call it SR flip-flop or RS flip-flop as you like. It has two output, one is Q, another is Q bar. That means whatever output here, it is the complementary form in below. That means if Q is equal to 0, then obviously Q bar is equal to 1. Now see what happened. If you go for the block diagram, it is a block diagram of RS flip-flop. Now the truth table of a RS flip-flop. See, always you remember that whatever the value of R is, that is the output of your flip-flop. That means, see here, the when both input are 1, it is no change. That means whatever output present over there, it will not changing. That means it is no much use. If those both input are 0, it is forbidden. Forbidden means we cannot use this state for this flip-flop. We can only use two state, one where S is 0, R is 1, or S is 1, R is 0. These two state we can use for this flip-flop. Now check with that by all those truth table we can check with. Suppose earlier in any stage, suppose Q is equal to 1 and Q bar is equal to 0 is present. Okay, now we give S is equal to 1, R is equal to 1. Now as per our truth table, these values should not be changed, because we see here for S is equal to 1, R is equal to 1, it is called no change in output. Let's see. See, when the previous output of this circuit was 1, then this 1 is fed to here. Am I right? universe? Suppose it is a device, it can have two state. One is present state, another is previous state. Suppose in output, it can store a value 1 and 0 earlier in previous state. Now see the connection. This AND gate got a input from the output of the above gate. See here. So if this value 1 previously stored, suppose someone stored previously value 1 at that flip-flop, then this value is fed to this gate, 2 number gate. Am I right or not? Okay. Now see, presently we give a input S is equal to 1, R is equal to 1. It is the current input. Now check what happen if we give S is equal to 1, R is equal to 1. See, this 1 fed to here and this 1 fed to here. Now this 1 1, the output would be what? Yeah, 0. See, here is a 0. Now this 0 is fed to that path and another input is 1. So 1 0, what will be the output of this NAND gate? One. So is it check the previous? Is it change the previous value or not? Is it change? Earlier the value was Q is equal to 1, Q bar is equal to 0. No. So that means here written, if we give the 2 input is 1, then output will no change. So it is justified. Now check with the another combination, then it will clear all more. Now suppose earlier Q, the value of Q was 0 and Q bar is 1. Now check. This 0 is fed to here. Now what will be the output of this NAND gate? NAND gate 2. What will be the value? 1. All are agreed? Yeah. So now this 1 is fed to here. Then what will be the output of this number 1 and NAND gate? Zero. So see, if the both input is 1, then whatever the value stored in previous, it will remain unchanged. So it is our truth table number 1. Am I right? For Q, no, it is the operation mode is written in language, but it is your output. Okay, now check the second one combination, it will clear. See, if S is equal to 0 and R is equal to 1, then what happen? Okay, suppose earlier it was 0 and it was 1. Now this 0 is fitted over here. Now what happened? What is the value of the this gate? Second gate? 1. Okay. Now this 1 fitted to over here. Now what will be the value? One. See, now here this 1 is come, but it is not unstable because it is not possible that q is equal to 1, q bar is equal to 1. So then this q again fit to here. Now what happened? When this q is equal to 1 fit to this gate, now what is the output of this gate? 0. Okay. Now we check it is stable or not. If this 0 goes to here, then what happen? 0, 0, 1. What will be the output of this gate? 1. So now it is stable. Because of this 0 it is 1, and because of this 1 it is 0. Now it is stable step arrive. Am I right? So your output is 1 here and 0 here. Now see what happened when this value s is equal to 0 and r is equal to 1 is given. Now your output is 1 and q bar is 0. Q is 1 and q bar is 0. Actually there is the two basic form. One is RS flip-flop with active low and another is RS flip-flop with active high. Okay, I think it will be better you just remember the active high one, because logically it is very correct. Logically it is very correct means, see, when set is 1 your circuit should set. When reset is 1 your circuit should reset. I tell you what is the difference. Active low and active high means when see here there is a bubble. Okay, there is a bubble. This bubble is for active low. It will work on the active low portion. That means one pulse have like that way. This pulse chain is going on. Okay, this gate is work for active low portion. Okay, and if it is active high, then it will change its state for this portion only. So for better way, forget about this circuit, remember the active high because it is universally granted and all time we are go for that. How it prepared? We prepared like same way, just we give a AND gate in a input and not get in a input of S and R. Is it clear? See, as for our SR flip-flop, I already told S for set, R for reset. So when S got 1, then your output should be set. Set means your output should be 1. Am I right or not? As per logic. Okay. For active high flip-flop, if your S is 1, then your output will be 1. But in case of active low, then S will be 0, that time your output will be 1, which I show here. See here, S is equal to 0 and your output is equal to 1 because it is active low. It will be active when your output is low. Is it clear? But logically, it will be better to remember for active high flip-flop when you give S is equal to 1 and your circuit is set. Is it clear, Srinivas? Okay, I just check. We now what we always go for active high input. Okay, we not concern active low. Forget about that. Whatever I taught, forget about that. See here. Now your circuit is when the S and R is both are 0, then your output is no change. Check with that. 0 here and 0 here. Sorry, 0 here and 0 here. And previously suppose it was 0 and it was 1. Check with that. This 0 is come here. And from that 0, here is 1. Now what will be the output of that? 1. Good. This 1 is go here. And this 0 is inverted by inverter 1. Then what will be the output of there? This is 0. So see, whatever the previously stored output is remain unchanged. When S and R both are 0, output unchanged. You see. Is it clear? Okay. Now as per our logic, if we want to set means we have to set our output, mainly output is Q. Okay. 1. Set means 1. Then what we should do? We have to do set S is equal to 1, Q is equal to 0, then our output should 1. Now check with that. Is it possible or not? See, we give S is equal to 1 and R is equal to 0, and previously suppose our Q is equal to 0 and QR is equal to 1. Now see what happened. See, same case in here, this 0 is come. Now this 0 converted to 1, 1 0 0, and here is 1 because of not NAND gate. Now this 1 is fitted over here, but this 1 inverted to here 0. Now what will be the output of this gate? Number 1 gate, what will be the output? Check with that, Srinivas. One input is 0, another is 1. What will be the output of NAND gate? See, yeah, I give 1 in S input. So, through this NOT gate, it will convert it to 0. And we got 1 from that Q bar, which is reached to the second input of this Q NAND gate, or number 1 NAND gate. Now this 1 and 0 make what? One. Yeah. Now check. Here Q is equal to 1, Q bar is equal to 1. It is not possible, because Q bar should be the complement form of Q. So it go for again to stable the circuit. This 1 come here. Now this 1 come here, and this is 1. So this should 0. Is it clear now? Now if this 0 goes here, then what happen? It is 1. Am I right? Now see, this circuit is completely stable and this logic also stable, that when we want to set our flip-flop, we have to give S1 and R0. S1 means set, because S denote for set. Is it clear now? It is much easier to remember the truth table. Okay, now when we have to reset our flip-flop, then what we should do? We should give 0 here and 1 here, because in reset terminal should be 1 and set terminal should be 0. Then our output will be reset. Clear, Srinivas? Okay, when we have to reset our output, reset means what? Reset means 0. So we need our output, that means Q is equal to 0. So for resetting our flip-flop, we need to do what? We need to give 1 on reset, because R input, because this R input means reset input. This reset input pin should be 1. Then our flip-flop will reset. Now check with this condition. Earlier our flip-flop was set. It is 1 and Q bar was 0. Now check. This 1 is come here. Now the terminal reset, the input of R is 1 now and S is 0 now. We give change. We need to reset. We go for the second condition. We check this second condition. Now this 1 come here and here will be 0. Now what will be the output? 1. Good. Now here is 1. Now this 1 is fitted here and here also. Now here also, because of that 0, 1 is reached. Now what will be the output of that? Zero. See, now it is stable. The Q is 0 and Q bar is 1. So see, just giving input R is equal to 1 and S is equal to 0, we can easily reset our result. That means when we have to store the content 0 in output, we have to give this combination, S is equal to 0, R is equal to 1, then our output will be 0. We reset our flip-flop. And when we have to store 1 in output, we have to give set. Set means set is S is equal to 1, R is equal to 0. Is it clear? Okay. Now the another condition left. If the both input is 1, we call this forbidden. Forbidden means we cannot use this state, because if we give, then race is running. Race running means never our output is stable. Check with that. See, we give both the input 1. Now what happen? Suppose earlier the output Q is equal to 0 and Q bar is equal to 1. Now this 0 is come here. Now this 1 return 0. Now what will be the output? 1. Am I right? Okay. This 1 fitted over here and this 1 is inverted to 0. Now what will be the output of that? Also 1. So it is not stable because both Q and Q bar should not be the same because it is the complementary form. So again this again it running to stable the state. Am I right? Again this process is running because it is not stable state. Am I right? Yeah. So then this 1 is go here. Now this output 1 is fed here. Now what happened? 1 0 what? What will be the output? 1. Again this 1, again this 1. Is it possible that both the output is 1? So that is why it is forbidden state. We cannot use that. Is it clear? It is a forbidden state. We cannot use S is equal to 1, R is equal to 1. Is it clear? RS flip flop. Good. Now RS flip flop should be made by the NOR gate also, but I think go for one gate, just a NAND gate. You just remember the NAND gate. Okay. You may build this type also, but it is better to remember with one gate. Now the clocked RS flip flop. This is already asked that what is the latch and what is the flip flop. I told that when flip flop has not got any clocked from outside, it is called the latch, and when you give the external clock to a flip flop, it is called the flip flop basically. See, in this case of a clocked RS flip flop, or for that matter any clock flip flop, the output change state as per the inputs only on the occurrence of clock pulses. That means what? In that case no clock is given. That means any time it is 1 and it is 0, the operation is running. But when we introduce a clock, suppose when we introduce a additional clock input for both the gate, then the operation only running when the clock is arrived. One clock arrive, one time check. Another clock arrive, another check. That is why clock is introduced. Neither every time your machine is running. So that is why this clock is introduced to your flip flops. No, if flip flop is come, you have to draw with clock, not latch. If they mention that RS latch, then you have to draw without clock. Is it clear, Siddharth? Now see first the picture. See here. Something is changing. first we go for, see, read. In the case of the clock RS flip-flop, or for that matter any clock flip-flop, the output change state as per the input only on the occurrence of clock pulse. The clock flip-flop could be a level trigger or an edge trigger one. The two types of discussed in the next section. For the we go for the active high. Here two state is given. It is active low and it is active high. We remember the active high one. Okay, that is why first we see this circuit. The description is written over there. If you understand the logic, you can write everything. See the circuit first. We know this circuit. Am I right? It was the latch circuit. Now to introduce the clock, we engage another NAND gate. See, here the NOT gate is removed because we use NAND gate instead of NOT gate. Only we use a NAND gate because NOT gate have single input. But now we need a clock again, clock as an input. That is why we introduce instead of NOT gate another NAND gate. And is it clear? 3 and 4. Because we cannot use NOT gate, because we need to another input as a clock there, and we know a NOT gate have only one input and one output. So where we give this clock? That is why instead of NAND gate, NOT gate, we use NAND gate. Is it clear now? The picture. Yeah, because of two input. Because in NOT gate we cannot give two input, na? Because one is ACE here and another is clock also. Clear, Srinivas? Okay. Now check the same. See, here the truth table is looking much more. Why? Because the condition is checked by 0 and condition checked by 1. When clock is 0, what happened? When clock is 1, what happened? That is why it is much more. And the truth table is looking big, but rest of thing is same. Why? See, the earlier it is an active high because no notch is there. That means when the positive pulse is fed, then it work. Okay, when the clock is 1, then it is work because it is a positive, no bubbles is there. Okay, now see, in earlier case we saw that if S is equal to 1 and R is equal to 0, then our output should be 1 set. Now for checking that, we take the previous output was 0 suppose, and it is 1, then it should be changed to 1 because we give S is equal to 1. Is it clear now? Okay, check. There is a 4 possibility because if the clock is 1, then this gate give one output. If the clock is 0, then give this another output. Am I right? Okay. Now, as per our knowledge in latch, we know that if S is equal to 1 and R is equal to 0, then our output will be 1, Q will be 1 and Q bar is equal to 0. Because S is equal to S means set, it will set the output 1. Am I right? Earlier we shown that if S is equal to 1 and R is equal to 0, then our output should be 1 and 0. Now for making it interesting, we take suppose earlier Q was 0 and Q bar was 1 earlier. Okay. Now what happened when we give S is equal to 1 and this clock is 1 here, then what happened? What will be the output of this gate? 3. Zero. Good. And what will be the output of 4? Gate 4. 1. Good. Now see, this 0 is come here and this, because of this 0, what will be the output of this gate? Gate 2. 1. Okay. Now this 1 go here. Now what will be the output of gate 1? 1. Okay. Now it is 1. But it is not possible both 1. That is why once again it repeat. Now this 1 feeded over here. Now it is also 1. Now what will be the output of gate 2 again? 0. Good. So 0 is come here. Now this 0 is fitted over here. Now what will be the output of this gate 1? 1. So now it reached to the stable state. See, when I give S is equal to 1, R is equal to 0, our circuit is set because our output is given 1. But it is, we know that in earlier truth table also, that S, suppose it is Q, 1, 0, then it will 1 and we check it, this circuit also, and it is satisfied. But think, here another input should treated, that is clock. This condition will fulfill when clock is 1. But when clock is 0, then what happen? If the clock is 0, then we have to also consider, am I right or not? Because this clock is simultaneously got 1 and 0, 1 and 0, because the pulse has a positive peak and negative peak also. Am I right now? Okay. Now check with that. If this pulse is 0, then this gate is 0. Now what will be the output of that? Gate 3, what will be the output of gate 3? 1. Good. Now what will be the output of gate 4? 1. Good. Now check. Suppose earlier this was 0 and this was 1. Now this 0 is come here. Okay. Now 1 0 0. What is the output of gate 2? Renu, concentrate. 1. It is an AND gate. Yeah, Siddharth, you are right. It is 1. Okay. Now this 1 is fitted over here. Okay. Now earlier this value is 1. Then what will be the output of our gate? 0. So is it our circuit is set? But it is a stable state. This 0 is come, it is 1, but it was the earlier state. But as per our logic, if we give S is equal to 1 and R is equal to 0, it should check. But in that case, it is not B. It was remain the previous state. Previous state. Whatever store in previous value, it will remain same. It will not set. It can be set only when the clock is 1. So see, because of the variation of the clock, we get the another set of output. Is it clear? UN means the previous state, not change. Whatever value was stored earlier, it remains same. Is it clear? In that way, for every input, for 1 there is a output, and we know the output in latch that will come when the clock is 1. But when the clock is 0, most of time you get no change. See here, when the clock is 0, the circuit was remain unchanged. What was the previous value? It was remain. It only work when clock is 1. Is it clear? Good. We know concentrate on active low. Not need that. We need that JK flip-flop. Okay, in RS flip-flop we just see that we cannot use the output goes unstable, because that case Q is equal to 1 we got, and Q bar is equal to again we got 1. It is not possible, because Q bar should be the complement of Q. That case we cannot use S is equal to 1, R is equal to 1. So to overcome this situation, we introduce a new flip-flop is called JK flip-flop. See here, a JK flip-flop behaves in the same fashion as in RS flip-flop, except for one of the enters in the function table. In the case RS flip-flop, the input S, R and R1. In case of a flip-flop with active high input and the input combination S is equal to S and R0, we cannot use for low input because it is prohibited. But in case of JK flip-flop with active high, the output of flip-flop toggles. That means if we give J is equal to 1, K is equal to 1, the output is toggle. Toggle mean, suppose the earlier output was Q is equal to 0, then it is toggle to 1. If both the input is 1, see, interesting one. We got a new state. If we give j is equal to 1, k is equal to 1, then the output is toggle. If earlier q is equal to 0, q bar is equal to 1, then it turned to q is equal to 1, q bar is equal to 0. If it is earlier state was q is equal to 1, q bar is equal to 0, then it is again changed. That means every time whenever we give j is equal to 1, k is equal to 1, the earlier state of the output is toggled. Is it clear? So how it is possible? We go for the circuit first. See, we already mentioned that we only modified the SR flip-flop to make a JK flip-flop. See, it is a circuit diagram of a JK flip-flop. See, it is a SR flip-flop, and for this SR flip-flop we introduce another AND gate here. Okay, and the feedback from this end is fed to this gate, and feedback from this gate is fed to the that gate. Now as the S, that case, set here the J, that means when we give J is equal to 1 and K is equal to 0, then our output will set. When we give J is equal to 0, K is equal to 1, then our output reset. But when we give both the 1, the output is toggle. Sorry. That means whatever value present over there, it will change to complement. Now check. See, when we give j is equal to 1 and k is equal to 0, suppose the output over here 0 and 1, then what happen? These 0 feed to there and these 1 feed to there. Now for this AND gate 1 1 what? Srinivas, it is AND gate, not a NOT gate. Not an AND gate, it is a AND gate. 1 1 1, yes, and it is 0 0 0. See, now S1 R0, so should be Q is equal to 1, because we know that in SR flip flop S got 1 and R got 0, then Q definitely 1. Am I right? Okay, now same thing, if J got 0 and K got 1, then what happened? Suppose earlier it was 1 and it was 0, then these 1 feeded over here and these 0 feeded here. Now this 0 0, it is 0 and 1 0 1 1, sorry, 1 1, it is 1. Am I right? For gate 2 it should 1, because here is 1 and K is 1. So see, S is equal to 0, R is equal to 1. So it should be reset. The value of Q will be 0. Same thing. Now the interesting thing, when the both input is 1, we mention that the output should toggle. Okay. Now check the logic, how it toggle. See, suppose the Q is 1 here and Q bar is 0 here. Now this 1 is fed here, 0 is fed here. Now tell me what will be the output of this first gate. Because here J is equal to 1 and feed is come 0. What will be the output? 0. Good. Now this feed is 1, K is 1. What will be the output? One. Good. Now check. S is equal to 0, R is equal to 1. Then what should be the Q? S got 0, R got 1. What should be the value of our output? Zero. Obviously. Reset. So see, the earlier it was 1 and it was 0, it is changed. It toggled. Now it is 0 and it is 1. Clear? Now again we check this condition. If the earlier value is 0 and 1, then what happened? This 0 was fitted over here and this 1 is fitted over here. Now that case, this J is got 1 and R got 0. So the output should set. In that way, we just check that if the both input J and K is 1, then our output is toggle. Whatever previous state value, it is changed. Is it clear now? So it is only difference the JK flip-flop with SR flip-flop, and this modification is take place because we can use this state, toggle state. Clear now? Okay, very good. You people are awesome. Very good response I got. Here lots of thing is more. You may know go for that. You go for this master slave JK flip flop. কোথায় চিত্তরঞ্জন কত টাকা নেবে দিয়ে দাও 30 করে সবাইকেই দিতে হয় দুর্গা পূজা পূজা সবাই করবে কোথায় বললো Okay. A deep flip-flop, also called delay flip-flop, can be used to provide temporary storage of 1 bit of information shown in the symbol function table. Okay. When the clock is active, the data bit 0 or 1 present on D, the transferred to the output. That means what? See here. The D flip-flop, when we have to store any value to C, it is our opposite form of a T flip-flop. See, earlier it is a J, it is a K, it is a Q, and it is a Q bar. So we write down the truth table of JK flip-flop. We know 0 0 NC, no change. 0 1 output is 0, 1 0 output is 1, and 1 1 it is toggle. Okay, now we introduce the JK flip-flop, D flip-flop, to use within the range of these two. That means what? We connect a inverter over here to K. Now it is a D input. So when we have to store 0 in output, if we give 0 on D, then what happens? J got 0 and K got 1, then output stored 0. Am I right? Because if J got 0, this inverter convert this, it is 1 here. So J0 K1 should be 0, output should 0. And when we give D is equal to 1, then what happen? Then this J got 1 and K got 0, then output is 1. So if you store the output 1, you have to give D1, and if you store output 0, then you have to give D0. So basically for storing bit in a output, we use this D flip-flop. Am I right? It is never come under the 0 0 condition and never come under the 1 1 condition. It is opposite of toggle flip-flop. What we see in toggle flip-flop? In toggle flip-flop, sorry, where do we go? In toggle flip-flop, we see that we use only the JK flip-flop two state. One is 0 0 and another is 1 1. When we give T is 0, then both the input is got 0, J and K 0. That is why our output is not changed. And when we give T is equal to 1, then both the input of J and K got 1, then the output is toggle, because we know the from JK flip-flop truth table that when J is equal to 1 and K is equal to 1, then our output is toggle. So it is a toggle flip-flop. But in toggle flip-flop, we cannot use this state where J is equal to 1, K is equal to 0 and J is equal to 0, K is equal to 1, because we shorted the both terminal and it is called T flip-flop. But in case of D flip-flop, we see it is a reverse one of T flip-flop, that we connect a inverter in between J and K terminal. That is why we cannot reach J is equal to 0, K is equal to 0 and J is equal to 1, K is equal to 1. We only reach J is equal to 0, K is equal to 1 and J is equal to 1, K is equal to 0. Now suppose we have to store 0 at output, then we give 0 in D flip-flop, then it will store 0 at output. Now check, wow, how it possible. Suppose we give 0 in D, then what happen? This 0 is come to the J and 1 is come to the K. Now as per our truth table, we know if J is equal to 0, K is equal to 1, then what happen on Q? It will 0 or not? See, this flip-flop is use only the complementary input form. That means when we give d is equal to 0 here, then what is k got? 1. Am I right? Now as per our jk truth table, if the j is 0 and k is 1, then q is 0 because it is the truth table of jk flip flop. And if j is equal to 1 and k is equal to 0, then q is equal to 1, it is jk flip flop truth table. So see here, now the j got 0 and k got 1. So from the jk truth table we easily got, then that time q should be 0 and q bar should be 1. So if we need to store 0 at the output, so we give 0 in d flip flop, then we can able to store 0 at output. Is it clear now, Srinivas? Yeah, same input is storing. When we have to store 1, then we give 1 at d flip flop input. Then the 1 is storing. So it is the use of a d flip flop. Is it clear now, Siddharth?